You've just spent your last savings to purchase a used second-class starship. She's a little rough around the edges, but she'll take care of you. Exploration isn't free, though. To support your wanderings, you'll have to take work to pay for supplies, and you're going to need more than credits to survive out there in the flat. Knowing where to find basic elements for fuel and for craft and repairs will also be key to your survival. Your ship's computer can help teach you what you need to stay alive. Work? Most of that will come from the corporation. They offer credits for materials and survey contracts. Some folks love the corporation. Others, well, most say they're not to be trusted. Either way, you'll need to keep your eyes open and watch your back.
Welcome aboard, Commander. I am Corey, the Cosmic Operations Research Interface. I will help maintain normal onboard operations and provide information as we explore the cosmos. Press the main control button below to open the ship's controls. The star chart allows you to observe, travel to, and analyze objects in the universe. Press the star chart button. We have a current corporation contract to acquire a spectrum from supernova 1987A, confirming the presence of sodium. Sounds like the corporation is testing you to see if you're someone they'll want to give contract work to in the future.
All right, so that is the intro to a learning video game. My name is Jeff Bary, and I am a professor at Colgate University. And what I want to do with this little breakout session is introduce you all to a first of its kind video game that is intended to teach students some fundamental astronomy at the introductory level, and that's at the collegiate introductory level. So I want to tell you a little bit about how I kind of came to be involved with this project, and then tell you a little bit about what I learned through the process about what what makes a game a learning game, what may make a game an effective learning tool, and then tell you a little bit about the process of building something that looks like this. So what you just saw was a little bit of an introduction and kind of gave you a beginning to a narrative and the game and the way that we eventually designed it. And we considered a whole host of different directions to go with it. But eventually it was a narrative driven game that covered 20 different missions. And the missions, we tried to cover a lot of the most important astronomical concepts that are covered in an intro class. And we did it both in terms of like the solar system side of things, the stellar side of things, and then like galactic and extragalactic stuff. And the way we eventually developed the game was to start kind of nearby with solar system topics and then move outward. And so, you know, the thing that was challenging there was trying to develop this narrative that was a cohesive story, but allowed us to very naturally tie together all of the concepts that you would encounter in Intro Astro. And I think the majority of Astro classes that are taught around the country, you either have, I think most of them would be 2 semesters where you have an intro to the solar system, followed by a second semester that might be just stellar astronomy, and then the rest of the universe, like galactic, extragalactic, and cosmology. That's the way we do it at Colgate. Some places will actually try and teach all of astronomy in one semester, which kind of blows my mind. But the way that I came to this project was through a new textbook that was being written by Adam Frank. And Adam is someone who shares some of my interests as a researcher. He studies star formation kind of on larger scales. He for the most part, has been interested in clouds, But I guess he's also been interested in outflows associated with young stars when they form. Anyway, so point is, we've had some overlaps in terms of our interest in research. And then he approached me early on when he was writing the book to read some chapters and give some comments. And so we went back and forth a little bit, he and I, and then also the editors at W.W. Norton, who is responsible for both the book and now also the video game. And they just kept giving me or asking me if I would get more and more involved in the book project. And eventually they asked me to develop 47 different computer-based interactives that dealt with very specific concepts in introductory astronomy. And then also helped kind of craft a little bit of the direction that the book took in terms of like really focusing on nature of science and building on this idea of really incorporating people that do science into the book. So after a year or two of that, they also wanted to build a video game. Building a video game, they're like, at some point, I'm not a gamer really much at all. I did grow up in the 70s and 80s and knew what Pong was and played, Nintendo games, Legend of Zelda, Mario Brothers, stuff like that. But when it came to video games, my peak was how good I was at Galaga. And then once games got a lot more complicated than that, I kind of moved away from being a gamer. So I'm not the most likely person to get involved in a project like this, I guess is what I'm trying to say there. But in terms of approaching it from someone who's really interested in teaching astronomy and doing it as effectively and efficiently as possible, I was intrigued because part of education, and maybe we don't do this so much at the collegiate level, but in secondary schools, you're sometimes being asked to play games, and those games are either helping you just kind of memorize facts or kind of develop a deeper understanding of concepts. And so this notion of competition or playing little games in terms of education or like a pedagogical approach is something that's not new. But applying it through a video game and doing it at this level is something that hasn't been done a lot. So the textbook, which was called At Play in the Cosmos, was called At Play in the Cosmos for this very reason, that from the beginning they had assumed there would be a video game, and that would be where the true play in the cosmos came from. So I'm gonna take you through a little bit of this first mission. As you saw, you got introduced to the star chart there. You got introduced to the fact that there's a corporation. The corporation is going to give you contracts and work, and they're asking you to do survey stuff and maybe some collection. You might have to do some collection stuff along the way, maybe just for yourself or for the corporation. But there's going to be some way of motivating some of the work that you're going to have to do in a given mission. And here's one example. These first three missions, and this is the first one, the first three missions are called Learning to Fly. And so what I've learned by working with the game developers is that this is pretty typical. It's an approach where at the very early part of the game itself kind of walks the player through how to play it. And so this is no different. And so you're going to think that this seems a bit pedantic or really just kind of leading in terms of like leading the student through. It's intentional because it's really, these first few missions are really teaching the student how to play the game. All right, so I'm going to turn the sound back on, and I'm just going to play a little bit. I might try and narrate over the sound, but we'll see how that goes. All right, I'm going to turn the sound effects back on. Maybe not the music.
To visit supernova 1987A, we need to travel to the Tarantula Nebula, which lies within a small satellite galaxy known as the Large Magellanic Cloud. Select the Large Magellanic Cloud.
All right, I want to say something about this star chart thing. So one of the challenges early on was trying to figure out how we were going to get the player to kind of navigate through the universe. And the game developers, after talking with us a lot about how I was going to build one of the Scale of the Universe interactive, we ended up settling on this idea of a star chart that kind of brought up, made a visual display of some of your options. Oftentimes, where it's possible, we put a scale bar up at the top to give a sense of scale associated with the image. That in gameplay lingo is called embedded learning. We're, in a sense, instructing the students about what the scale of the universe is. And as they kind of zoom in and zoom out, that scale bar will often be there. And over time, our hope is that students will kind of pay attention to it and will develop some sort of a sense of what the scale of the universe is. All right, so Corey here, who kind of walks you through and gives you little factoids here and there, which is super intentional. And I spent a lot of time writing lines for Corey to say. She's asked us to click on the Large Magellanic Cloud. So you click on the Large Magellanic Cloud, and she just said, but I've got her cut off right now, to zoom for a closer look. And you zoom into the Magellanic Cloud, and she's put a little box around the Tarantula Nebula, which happens to be where we're going to find supernova 1987A. And now we're going to end up FTLing in. Now, some of you who might be sci-fi aficionados might recognize the term FTL. It was a new one on me, but it just rolls off the tongue now because I've been working on this project for several years. FTL just stands for faster than light travel. And you might be saying to yourself, that doesn't exist. And it does not. But we had to break the rules of the universe as we understand them currently to make the game playable and to permit these types of things to happen. So you're going to travel faster than the speed of light and go to the edge of faster than light technology to the Large Magellanic Cloud to check out supernova 1987A. And in my thinking, when we were developing a progression, I really wanted to put something up front at the beginning of the game that was aesthetically interesting. And the supernova 1987A was one of the first things that came to mind. And hence, here it is. So the next thing that this takes us to is the tools. And I'm going to go ahead and cut Corey back on here so we can hear her talk about the tools. I need to get back to the star chart. Excuse me. All right, I'm going to click on the tools.
This is a list of all astronomy tools available for us to use. Select the spectrum analyzer and press Begin Analysis.
All right, so this is another interesting point about the game development. And let me get back to my tools here. In terms of like the learning, we were trying to figure out how are we going to get students to engage with the game in a way that is going to introduce them to the concepts that we judged are the most important that you will find in an introductory astronomy class, and then have them interact with them repeatedly throughout the game, both to reinforce them, but to also get them to engage with them and use them, and not just kind of imagine them as these theoretical concepts, but concepts that they can actually apply themselves. And so we ended up settling on 7 tools: spectrum analyzer, the mass analyzer, small angle formula, something that's going to allow us to measure radial velocities, luminosity tool, a black body analyzer, and a light curve analyzer. So, of course, you can look for transits with the light curve analyzer. You can look for radial velocity shifts for planets, exoplanets with the radial velocity tool. Small angle formula, they can get a sense of that relationship between distance and the angular sizes of objects. So in our limited budget, we were able to come up with 7 tools that we could have the game developers design and build and make part of kind of like your onboard operations system. So here's your first tool usage. And since the game is still trying to teach the player how to navigate through it, Corey just tells you that, okay, what you need to do here is pick the spectrum analyzer. And then you click on begin analysis. The little graphic here is supposed to show, that spectra are formed by light being sent through a dispersive element. And so it shows the little prism there, and then the rainbow coming out the other side. And you have to take a measurement, right? So this was really important to me and the game developers when we were thinking about taking the student and kind of placing them in the role of being a scientist, which really, when I came to the realization that I was going to be able to do that in some sort of meaningful way with video game, that I could take the player and kind of put them in the position of a scientist and ask them to collect some data, right? Like they're making a measurement here. And so you hit the button, measure, and evidently neutral argon doesn't have any lines in the optical, which still frustrates me that this is the first thing a player sees, but we're still getting there. And then you kind of click through to compare your library spectra with the observed spectra above. And there's ionized helium, but of course that's not what you're seeing the lines from in the observed spectrum. And there is a library spectrum of sodium, and it is a match. So what you would do once you scroll through and find your match, you just hit confirm match. And then Corey just said, and you didn't hear her, she said that the presence of sodium was confirmed. And now you've finished your survey of the supernova 1987A. Now she's making a suggestion that we go visit the Orion Nebula, right? And we're going to just be on our way back to the solar system anyway. So she suggests we just stop off in the Orion Nebula.
You can zoom out a level with the buttons on the left side of the star chart.
So you go
the
back in.
Orion Nebula is located in the Orion spur of the Milky Way galaxy.
So you go back to your star chart. You zoom out. Get back to the point where you see the Milky Way. We know we have to go into the Milky Way. Zoom back in. And then she tells you that it's in the Orion spur, so you can zoom in.
FTL to the Orion Nebula.
Still helping the player out considerably.
Great work. Looks like you're getting the hang of things.
All right. And that right there was really important to me, too, that we got the Orion Nebula in there, star forming region. Very, very important to my own work, but also something that students might recognize, and also something that's really aesthetically interesting and has a bit of a wow factor to it. So that's why we put that kind of up front.
Welcome to the Orion Nebula, Commander. At a distance from the Earth of only 400 parsecs, this massive cloud reveals much about how stars and planetary systems form from collapsing regions of gas and dust. Orion 114426 is a protoplanetary disk system within the Orion Nebula. Our solar system would have looked very similar to this system when it was roughly 1 million years old. Shall we measure the diameter and compare it to our home solar system? Open the star chart.
Yes, we shall, because the player really doesn't have any choice here. They have to kind of follow
Select
along.
region 1 and zoom in for a closer look. Select Orion to access the Tools menu.
So again, this is an actual probe lid. That is its actual location in the Orion
Now
Nebula.
select the Tools button. Select the small angle formula to measure the diameter.
Okay, and here's your first use of the small angle formula. All right, and so this is a place. I hope I turn this off so we don't have to hear that clicking. So here's a place that we spent a lot of time thinking about how we were going to pull this off, because lots of introductory astronomy classes are taught really without any math required. And that is not the way that I teach my course, and that's not the way that Adam teaches his course. And so we wanted there at least to be the opportunity for students to engage with some kind of basic equation, some kind of quantitative work. And in this case, to me, it just goes along with trying to teach students quantitative things, or these little basic equations, or the measuring of stuff is where I was going with that. So anytime they're going to make a measurement, they should have some numbers, and they should have to deal with some numbers. They should have to deal with some numbers and get some sort of quantitative result. So even in a class where they aren't really expected to do any calculations, the way that we built this into the game is that they will take the numbers that they measure. And so in this case, they aren't really measuring the distance, they're actually being given the distance. And then they have to drop it into the equation in the appropriate place. Now they're giving lots of hints there, because if you notice, the color match. So the color of the distance actually matched the variable, the location of the variable in the equation. All right, now we're going to measure the angular size of the probe lid by hitting the button measure. And those two lines snap down to the dash circle here, which is, for me, a pretty good graphical representation of what it means to use a small angle formula. And then the calculation is done for them, right, with the appropriate units and everything. And again, up here we put the bar that actually shows the physical size of the object that's been measured to one more time just make that connection. So anytime students are going to be doing something that is quantitative, and they'll be using a tool that will make a quantitative measurement rather than doing spectroscopy, they will have to take a value and put it in the appropriate location of the equation, hopefully to build some sort of at least qualitative understanding of how numbers depend on each other, and think about things in terms of proportions. But they won't have to calculate anything. And this gets around another issue that comes up with the building of video games, is that sometimes gameplay can be interrupted too much by some calculation that you might have to make, or something that would seem really sort of pedantic and very much just in the mode of solving a problem, almost like a pencil and paper problem. And you don't really want to do that in a game, because it makes the game feel much less like a game. And in a lot of cases, there will be situations where people will have made a game, but the game itself will be just a series of problems that students have to solve with a weak narrative that might be intended to draw them together. That has a name in the game development community, and they call that chocolate covered broccoli, right? So what you're doing is you're trying to disguise the fact that what you're having the student do is pretty much just solve problems as they typically would, and it's doing it in a way that doesn't really feel like a true game. And so we wanted to avoid that as much as possible, but we're trying to strike a balance where students could feel like they're playing a game, but also have the opportunity to do some of that problem solving that an instructor like myself would really want them to do. So that's sort of the rationale that we came up with for the way we built those quantitative tools into like the user interface. All right, I'm going to bring this.
Using our FTL drive.
All right, so we're now going to fly to the Proplid.
Rotation and contraction of the planet formed Orion 114-126 caused it to flatten into a disc-like reservoir of planet-making material. Note the presence of the forming star at the center of the protoplanetary disk. Commander, I recommend we FTL even closer to examine this forming planetary system.
All right, so the game developers, some of them are artists, and so they took just this concept of a protoplanetary disk and worked with me to try and get it to look more realistic, right? So hopefully we've got the size of the star in the center to be about right, given the scale of the disk. Yeah, it's not perfect, but there was only so much we were going to be able to do going back and forth from several states away. We only got a couple times to actually sit next to each other and work on the project, but they were talented artists, and they were able to take their artwork and then digitize it and put it in a game like this. So
please stay alert, Commander, and open the star chart.
We're flying in now to the Proplid. This is probably the last bit of gameplay I'm going to show you.
We've arrived at our destination. Use the ion thrusters and fly to the checkpoint.
All right, so we are, orbiting around the planet pretty much with these Proplids. We got one of them that's really rotating there, which is nice. You can see that there's a little bit of dust in the medium that we're flying, what we're going to be flying through in just a second. And so they're planets in the midst of forming here, which was what we were trying to get across.
Commander, when you use the velocity slider, I will use the ship's thrusters to control our speed by accelerating and decelerating as needed. Interesting, Commander. I believe I have detected debris of some sort. I recommend you carefully fly a little closer to investigate. Let's stop the thrusters.
So when we first play tested the game, when we first play tested the game, a lot of people were like, "Hey, when the ship stops, the ship's thrusters really need to fire in the backwards direction," and that was just going to be a whole lot more work for the game developers. And so the way we solve that issue was we had Corey say that she would just automatically kind of slow the ship down, and she would fire the thrusters herself, and so you wouldn't have to worry about kind of gauging things yourself over here with your slider in terms of like speeding up or slowing down. So she's asking us right now to deploy the drone. So you have a little onboard drone that you can send out to collect things. It also is a mining drone, so at some point you'll use it in the game to mine metals off of asteroids. And in this case, though, you're being asked to go into this debris from this wrecked out alien ship, which no one has discovered aliens yet. So that's pretty interesting. Whoa. All right. That's supposed to... We're supposed to take on some damage there. All right, I'm following the yellow arrow. Oh, I thought I had gotten that thing. Oh, here we go. All right. I have to get back to the ship. Man. All right. So luckily, you don't have to slow down and park the drone softly. You can just kind of slam it right back into the ship and kind of takes care of itself. All right. So here she says she doesn't know what that data module was that you just picked up, but it definitely looked like it was of an alien variety. So,
Commander, we are under attack. Our thrusters have suffered significant damage. We are taking damage. We need to get out of here. If you act with some haste, I believe we can escape using the FTL drive. And by haste, I do mean right now. Quickly, FTL to us. Commander, we've arrived at our destination. Nice work, Commander. We are still in one piece.
all right, so that really set up the narrative that drives most of the rest of the missions. Right, you got attacked by an unknown spacecraft, and now you've taken damage. And this next mission is going to ask you to go mine some material so you can actually repair your ship. And then it goes on from there. So the next one, your mining mission is going to be to the asteroid belt. You're going to end up going to Venus and Mars to search for evidence of terraforming, because this corporation is interested in terraforming either Venus or Mars. And that is, at least according to the other people who are flying these Sagan-class spaceships around the galaxy. So I think I've touched on just about everything that I wanted to in terms of like the game design and the development. You know, one of the main ideas about why Norton wanted to build a game like this and why Adam was really passionate about it is that this generation now has grown up playing video games. And you know, when you're thinking about an introductory astronomy class and what our goals are with a course like that, it's really to teach students about basic science, right? Getting them to understand what it means to collect data and how you interpret that data, and what scientific knowledge then is all about, since most of it is rooted on our observations and the uncertainties and stuff that come along with that. So we thought that maybe this would be a way to both engage them in the content, maybe inspire them a little bit, but really put them in the situation of the scientists and allow them to explore and play and embed a lot of that learning that we would want them to do by reading a book or solving homework problems, but be able to get it through a video game. And in a way, you're kind of tricking them into learning just through play. And so, you know, we just built 2 more missions onto the game. So this version that I'm showing you right now doesn't have 20 missions. It has 22 missions. And that mission that I had mentioned about the terraforming was one of the new missions. One of the other new missions was a visit to Jupiter and to Europa. That mission actually kind of sets you up as if you're going to go to Europa and you're going to kind of bust through the crust of the moon and go dive down into the subcrust mantle ocean, which we definitely could not build into the game. So I was I'm misleading the players and even like the professors at that point. But nonetheless, you know, that was another mission that we built into the game. And then we also have students visit Enceladus now. So we added a lot more solar system stuff to this version 2.0. I don't know exactly how many students have used the game across the country, but in terms of versions that have been sold to different institutions, some have been returned because they weren't used, but it's in the tens of thousands. So the success that the game has had is what led us to add a little bit more to it, because the publishers, W.W. Norton, felt like it was successful enough that it merited an improvement, which is really good. We're happy. We're pretty happy about that.